Hi, it's Cameron Gibelyou again, and this time I'm talking about what we see when we look out into space. If you're taking big history, this talk will help you understand material from a few of the units on astronomy and cosmology, and will help you understand the immensity of the universe around us. When you look up at the night sky, you probably like to admire the stars, and with good reason, because stars are beautiful and fascinating, and the practices of stargazing and studying the stars go back to ancient times. But there's another fascinating aspect of the night sky that you might not think about as much. The sky is mostly dark. Even if you're in a place away from city lights, a place where you can see a huge number of stars, there are plenty of dark patches in between the stars. Why is that? You probably haven't thought to wonder about this before, because it just seems so natural that of course there are stars in the sky, and then dark patches between them. But those dark patches can tell you a lot. They indicate something about our universe's history. Imagine for a moment that the universe is infinitely big and infinitely old, so that it goes on forever in space, and it's existed forever in time. This is actually what many scientists thought was the case before the past several decades. But think about what this would mean. From our location on Earth, we could look out, and in any direction we looked in the sky, we'd see a star. Although more distant stars would be dimmer than more nearby stars, the sheer number of distant stars would make up for their distance, and the total light from all the infinite stars in the universe would completely fill up our night sky. There wouldn't be darkness at all. This argument is known as Olber's paradox, and it tells us that we probably shouldn't think about the universe as being both infinite in all directions and having existed forever in the past. Cosmologists still think that the universe may be infinite in space, though we can't say for sure. But the time component is the one that they're much more confident about. Our universe hasn't been around forever, but rather started 13.7 billion years ago in the Big Bang. What this means is that even if the universe is infinite in space, light simply hasn't had enough time to travel from all parts of the universe to reach us here and now. Light doesn't travel infinitely fast. It travels at 186,000 miles per second, or 300,000 kilometers per second, or roughly 1 foot per nanosecond. And so it can only travel a certain distance, even in 13.7 billion years. Any parts of the universe from which light hasn't had enough time to travel to us, we simply have no way of knowing about, since nothing can travel faster than light. Those unknown and unknowable parts of the universe are said to be beyond our horizon, and the parts of the universe from which light has had enough time to travel are referred to as the observable universe. Looking out into the observable universe means looking back in time. You see your friends across the room as they were a fraction of a second ago, because it took light that long to travel from them. We see the moon as it was a little over a second ago, and the sun as it was over 8 minutes ago, because that's how long it took the light to travel from there to the Earth. If we peer further out into space, we peer even further back in time. We see nearby stars as they were several years ago. We see the center of our galaxy as it was almost 30,000 years ago, and we see the Andromeda Galaxy as it was some 2.5 million years ago. The Andromeda Galaxy is the most distant object you can see at night with the naked eye, but if you were to use a powerful telescope to peer at even more distant galaxies, you would see some of those galaxies as they were hundreds of millions or even billions of years ago. In the study of history, this is the one chance you get to directly see things as they were in the past. Only we don't get to see what our region of the universe was like in the distant past, but what other parts of the universe looked like in the past. And the further out we look, the further back in time we see. If we look back far enough in time, by looking far enough out into space, we see that galaxies are typically smaller and less regularly shaped in the early universe than they are in the present universe. This makes sense if we think of the galaxies in today's universe as having been formed from the building blocks of earlier, smaller galaxies merging together over cosmic time, millions to billions of years. Some of the most distant galaxies astronomers have seen are in this image, the Hubble Ultra Deep Field, which was obtained by pointing the Hubble Space Telescope at the same tiny patch of sky for the equivalent of several days. Because these galaxies are so distant, we see some of them as they were approximately 13 billion years in the past. If we look even further out into space, we can see the oldest light in the universe. The cosmic microwave background, or CMB, is the light that bathed the universe 380,000 years after the Big Bang, 13.7 billion years ago, and it still carries the imprint of the conditions of the universe at that time. We can observe the CMB, and in fact have made detailed measurements of it, but we can't see beyond the CMB, no matter where we observe from or how good our observing technology is. The CMB is like a cloud that shrouds everything further away in space, and farther back in time, from our view. Just like you can't see what's beyond a cloud, you can't see what's beyond the CMB, no matter how powerful your telescope. This diagram shows what's happening when we peer out into the universe. The Hubble Space Telescope, at the left side of this diagram, can see some unimaginably distant galaxies, as shown in the Hubble Ultra Deep Field image. But it can't penetrate all the way back to the time of the first stars. Beyond that, even further in the past, other instruments have detected the CMB, but no instruments can directly detect light from beyond the CMB. We can still infer something about what happened in the early universe before 380,000 years after the Big Bang, though, because we can take what we know about the expansion of the universe and use it to rewind the universe to before this time. Astrophysicists and cosmologists sometimes trace the universe so far back in time that everything we now see was contained in a region smaller than the size of an atom in today's universe. Although this involves somewhat more speculation than our knowledge of the later universe, it helps us develop an understanding of the conditions in the universe, going almost all the way back to the Big Bang. But it's also worth remembering that the 380,000 years that we can't see is a very tiny sliver of our universe's history, and the vast majority of the 13.7 billion year history of the universe is actually visible to us. This is a big reason why astronomers have such a good understanding of the universe's basic properties and how the universe has changed over time.